10, lesson 1 on solving quadratic equations by graphing. There are other methods for learning how to solve these, which is using what's called the quadratic formula and also solving by factoring, but with our time crunch, we're really just focusing on one method, which is solving by graphing. So that being said, first off, what is a quadratic equation? So it has to have two key components, okay? The first part is that it has to have an x squared term. In order to be a quadratic, it has to be to the second power. So you need that quadratic term. Okay, and then to be an equation, obviously it has to have an equal sign. Okay, now the rest of this, the linear term and the constant term, that's what you see here, what you see most of the time, but one or both of these could be gone and it would still be a quadratic equation if it was just this part. So for instance, if you had y equals 3x squared and there was no, bx term or c term, I mean, this is still a quadratic equation. Okay, all right, so the exponent needs to be 2 so that we have that quadratic equation just like the factoring we're doing from the last unit. Okay, so then really a lot of this is more just understanding the vocabulary. So let's remember that solutions, zeros, and roots all mean the same thing. Okay, and they are related with the x-intercepts, okay? So to solve means to find an x value when y is 0. So when we see this graph, for instance, I want to know what are the x values when y is 0. In other words, we want to find where they cross the x-axis, or the x-intercepts. So you notice here there are two of them, and they are at x values of 2 and -2. So then those would just be our solutions, -2 and 2. And the only thing that would be different here is just we need to remember x-intercepts are written like points. So if you're asked for the x-intercepts, you would write these as coordinate points. So for instance, -2, 0, and 2, 0. Okay? So you just have to write them in that way so that you get them as a coordinate point. All right? Now, that being said, if this said find the solution, find the roots, or find the zeros, you would still answer in the same way. So they're synonyms of each other. Okay, so here we saw two solutions, but does that always have to be the case? No. So when you graph it, these are the three possibilities. It doesn't cross the x-axis at all, which means it has no solutions. Technically, it's no real solutions. Later on in your math career, you would learn how to find the imaginary or non-real solutions, but for right now, we would say there are no solutions or no real solutions. The graph can touch the x-axis one time, like it does here, which would be one solution, or it can do what it does probably the majority of the time, which is to have two solutions, or 2 times it crosses the x-axis. Okay? So then we just looking through some review. So for instance here, how many solutions does this have? Well, it crosses what? Once, twice, so it has 2 solutions. What are they? Well, the x value here is 0, the x value here is 2, so solutions are at 0 and 2. And that's really it. Okay? So just remember root solutions, x-intercepts, zeros, they all kind of mean those same things. The value of x when we cross the x-axis for the graph. Again, the only difference being the x-intercepts, you'd need to write them like a coordinate point, whereas the roots, zeros, and solutions, you just write x equals whatever the number is. Okay, so what would we see like for this if it was on the SOL, right? So here's this graph of h of x, which just describes this graph. What are the zeros? So again, what does that mean? What are the values of x when we cross the x-axis? Well, here they are, 4 and -2. Oh, so there you go, -2 and 4. Why? These are the x values when when the graph really crosses the x-axis, right? So there you go. All right, so what about, here again, it's just the same question showing the explanation. The zeros are the x-intercepts, right? So the answers are a list of the x values where it crosses the x-axis. Boom, boom, -2 and 4, which is why it was this answer. All right, so what about here? Let's look at the difference between when you're asked for x-intercepts versus roots in terms of how you answer it. What are the x-intercepts for the red parabola? So here's one at -2, and here's one at -4. And then we need to write them, since it asks us for x-intercepts, we do have to write them like coordinate points. So we'd write, for instance, -4, 0, and 2, 0. What are the roots for the blue parabola? So again, what do we see here? Well, that's at what, 4? That's at what, 6? Okay, so what about for the blue parabola? How about 4, 0, and 6, 0, right? So boom, boom, right? Now, This would be how you'd answer this if it asked for x-intercepts. It doesn't. It says roots. So instead of this, you just say x equals 4, comma, x equals 6. You also can feel free just to write it like this, 4, comma 6. That works as well. And this is what we put for the roots, but it could say roots here, it could say solutions here, it could say our zeros, and we would answer it the same way. The only difference is the x-intercepts we answer with the coordinate point. Alright, so another one like that. How many zeros does this have? Well, it hits one time right there. So 1, what's the solution at? Well, let's just count. 1, 2, 3. 3, that's it. It's a 3. Okay, so it's really just looking at the graph here, right? So what about here? Does this cross the x-axis? No. So why does it have no solutions? It never crosses the x-axis, right? And that's it. We're just looking at that x-axis. All right, so how many possible solutions are there in a quadratic equation? Well, you could have 0, you could have 1, or you could have 2. Now it says draw a graph that has no solution. So we needed to not cross the x-axis. So it could look like that and open up, or it could look like this and open down, right? But it has to not cross the x-axis. All right, here, draw a quadratic graph that has 2 roots. Okay, well now what could happen? It could open up and cross like this. It could open down and cross like this, right? 2 times. What are the other names for solutions of a quadratic equation? Well, they're what? Roots and zeros, and then the x-intercepts, but those must be written as a point, right? So putting it as a coordinate point, 4, comma 0, negative 2, comma 0, whatever. All right, so what if you don't have the graph? So it says, hey, here's this equation. What are the root solution zeros, right? Well, then let's graph it. So open your Desmos graphing calculator, and then we just want to go in here and type in what we see. Now, it needs to be set equal to 0. Now, in this case, it is. Next screen, we'll see where it isn't. So I see x squared plus 5x plus 6. So I'm just going to type that in. All right, so I click here, open up my keyboard. I'm going to go x squared plus 5x plus 6. Boom. And now, boom, boom, there we go. Negative 2 and negative 3. So how many solutions are there? There's 2. What are they? Negative 3 and negative 2. Okay. So there are 2 solutions. What are they? Negative 3 and negative 2. Done. Okay, so what if it's not set equal to 0? Then get it set equal to 0 to start. So here it was minus 10. So this is the only time we're actually having to actually solve anything. So we're going to add 10 to both sides so that we can get it set equal to 0. So now I get 0 equals x squared plus 10x, and then 6 plus 10 gives me 16. So now I'm going to graph this, as bad as that handwriting is. So x squared plus 10x plus 16. So x squared, I can just replace this. Plus 10x plus 16. There we go. Boom. Boom. So 2 solutions, roots are zeros, and they're at negative 8 and negative 2. How many solutions? 2. What are they at? Negative 8 and negative 2. And that's pretty much it. So the only thing that you'd see different, and we'll just touch on what this button means when we do it, is what if they aren't integers? So notice how all these answers have just been, numbers with no decimals, integers, right? So what if all of a sudden instead of this was a plus 15? And now notice you get these little decimals, right? Okay, so I can keep this decimal right here, right, and say, hey, negative whatever it is, 1.838. So I could go over here and type that in, negative 1.838. What if I need that as a fraction? Well, I'm just going to click here, and it's going to give it to me as a fraction. So this button allows us to convert a decimal to a fraction. Now, obviously, all of them are not anywhere near this complicated, so I'll switch this just so you can see. So let's say I had this, and then I had here. Okay, so now I see negative 2.5. So I could go in here, type in negative 2.5, and click, and then there you go. Okay, so understand if it's multiple choice, we need to be able to convert from the decimal to the fraction, or back and forth, right? And that's what this button out here lets us do. So just to answer this question, what does this button mean? It's to convert from a decimal to a fraction. Okay? Alright, so that's our content here. Make sure you go through screens 17 through 28 to help you learn this content, and then check back later for my feedback. Hope this helps.